All right, welcome back. So we're on our Unit 3 of Module 5, Topic 1, Probability. And for some reason the video kind of glitched out here, so we missed the first part. So I'm just going to tell you what we did. Okay, so exploring probability. We have this random generator where we can drop dots. Some go in, some go out. Then it said click reset, boom, hit the example button, boom. And we had 785 of the 1,000 inside, 215 of the 1,000 outside. Calculate 785 divided by 1,000, but it's percent, so we got to multiply by 100. Of the 100%, 21.5% outside. Okay, now it talks about the idea that the circle has an area of 400 units. Then the area of the circle is 78% of the whole square. So I fill 78% of this square, right? Okay, now if you take 78% of the 400, so 400 times 0.785, you get 314 square units. The area of a circle is given by the formula A equals pi r squared, where r represents the length of the radius. The circle in the Explorer tool has a radius of approximately 10 units and an area of 100 pi. Thus, the probability experiment shows that the approximate value of pi is 314 divided by 100, 3.14. Talk about a canned problem. All right, let's see how we can finish this video, okay? So, select the background which shows two circles partly overlapping, then press example to drop 1,000. So, two circles, drop 1,000, oh, no. Example, sorry, reset, to example, it's going to drop 1,000. A total of 1,000 were dropped in the left circle, left, 227 plus 122, and points were dropped in the right circle, 122 plus 227. And blank were dropped in the right circle, and blank were dropped to the overlap. Okay, we have an overlap. Now, represent the probability of a point landing in the left, probability of it landing in the right. If you know that a point landed in the right circle, this does not change its probability of being in the left circle. This means that the L and R are independent events. Thus, the probability of a point landing in the overlap is times. Okay. Now, the denominator of the fraction of its own outcomes will be R. Okay, the numerator of the probability fraction, which represents the total outcome, will be when the two events A and B are independent, the probability of A given A can be written as or P of B can be written as right there. Yep. Okay, and that's all formula driven, and we'll have a cheat sheet for it. Okay. Okay, so now example. One circle inside another circle, and hit the example button. The probability of falling inside the large circle is approximately 63. Probability of a point falling inside the large circle. 785. Got to put them both together. The probability of falling inside just the small circle is 155. Okay, now, probability of a point falling in the large circle, and let P of S calculate the probability and the probability. L, large and small, is 785. $785. Getting it determined above the probability oh 0.785 let P of L represent the probability of falling in a large circle, 630, and let P of S the probability of falling in the small circle. So 630, I'm lost. Probability of landing in both circles is equal to the probability of landing in just the small circle, 0.155. So 0.155 divided by 0.785. I had all the decimals wrong today. Now, the large and the small, 0.155. Probability of the small is 0.155. So it's going to be 1. Okay. They are not independent. Okay? Alright. Sorry that was confusing. Sorry the video went bad on us, but we only got one unit left. Cool.